Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Kern Schools Federal Credit Union, California Resources Corporation, Bakersfield West Rotary Stroop Family Foundation, Panama Buena Vista Union School District, Bakersfield City School District, and the Kern High School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
Well, good afternoon and welcome to Do the Math. I'm Michael.
And I'm Tracy. And you can reach us at Bakersfield at 661-636-4357. In San Luis Obispo, it's toll free at 1-866-636-6284. Don't forget email dothemath@kern.org. Watch us online at dothemathonline.net and social media, Facebook, Instagram, Twitter, and YouTube.
All right, so as Tracy said, a lot of different ways you can contact us here at Do the Math, and nice to have you back.
Glad to be back.
There you go. We'll get you to work today, I know that. You know what, we have a couple of kids waiting online already to call in with their problems. We have a very special guest in studio. We'll be going out and about, but before we do any of that, let's first take a look at today's Math in the News. All right, so the photograph that we have up on the board is one quite familiar to people in Kern County and basically all of California probably, as well as other parts of the United States. Do you know what those are called?
They pump oil.
Right, they pump oil, and sometimes people call them grasshoppers because they look kind of like a grasshopper, but I think they're actually sucker pumps because they will suck the oil out instead of having a derrick or something like that that
does the backwards.
that you're supposed to be seeing all the time. But I found an article, and it has to do with oil, so that's why I started off with this, all right? Now, there's big money in oil. You know this, right? Big money in oil. And there was a word, and it's under here, it's oil and air, all right? So if you're in oil and air, you have made your millions from oil. Now, have you ever heard of oil and air before? No, I hadn't either. That's why I had to go ahead and say, all right, let's see if this really is and what's going on with it. So in oil and air, that was what the article was about. And so I figured, all right, this is going to be easy enough to tie math into. So we can take a look at the production of crude oil during the last almost 100 years, right, because we're just about at 2020. And simply by looking at different types of graphs, students will be able to take that information and they can make different types of problems out of them. So they can see that if a question would be, when was there a major drop in the production of crude oil? So a student should be able to look at the graph and figure out that, all right, well, here we had a major drop, right, between 1980 and 2000, and then also a little bit right after the new millennium, right? So being able to read a graph is one of those things. Another type of graph is a pictograph. So we see that a barrel of oil, most of it is being used to produce gasoline, right? So we've got just about 20% there. The other major part would be diesel and then the other products. So we can see other distillates, heavy fuel oil and things like that. But the other products is one thing that I was interested in. It's like, what are the other products? So do you have any idea of some of the other products that are made when a barrel of oil is produced?
So I'm thinking like tires and things like that, because petroleum's already on there, but maybe.
Right, so let's take a look right here. So we have a big graphic right here. We can take a look at some of the different things that are made with oil. Right, so that we can see in the building and home, paintbrushes, extension cords, tires right there, pylons, pots and pans, Toys, pacifiers, glasses, lawn chairs, hoses, sneakers, an assortment of goods right there. Because a lot of people aren't quite familiar with, all right, well, there's a lot of oil in Kern County and Bakersfield, so they just make a lot of oil and gasoline, but there's more to it than that. And then being able to read graphs is how we tie the math into that, and that is today's Math in the News. 636-4357 is the phone number. All started with an oil and air. I, unfortunately, have not become an oil and air, which is why we're here helping you do your math homework. Anyway, in studio with us right now, we have Brian. How are you today, Brian?
I'm well.
Why don't you let everybody know where you go to school and what grade you're in?
I go to Ronald Reagan Elementary School, and I'm in 6th grade.
How's 6th grade going?
It's pretty fun.
It's pretty fun? What's the best thing about 6th grade then, if it's pretty fun? If somebody said, listen, you're having a good year in 6th grade, it's more than halfway over, what's the best thing about 6th grade so far this year?
I would probably say GATE.
So you like going to your GATE program?
Yeah.
All right. And have you already been to Camp Keep?
Yes, I have.
And you had an opportunity to go over there for that week?
Yes.
What was one thing that you remember still about Camp Keep? Because it was only a couple of months ago probably, right?
Yeah.
Okay.
I remember hiking, and we found some creatures, and then we learned about the creatures we encountered in the wild.
Okay. So it was a pretty good week, right?
Yeah.
How was it as far as the weather goes? Was it really cold, really hot, or?
It was usually cold in the morning, and it got warmer towards the afternoon, and it got a little bit colder at nighttime.
Okay. How was the food?
It was great.
It was great.
Yeah.
You know what? Every single student that comes in and talks about Camp Keep, they're away from home for a week, sometimes their first time away, and they always comment on how good the food was. So I'm glad to hear that you enjoyed the food. You ready to do a little bit of math?
Yeah.
All right, head on over to the board real quick. This is one of the problems that you have on your homework. And it says to find the greatest common factor. So you can just go ahead and write GCF up there if you want. The greatest common factor of 48 and 28. So 48 and 28. And as you're doing the problem, I need you to explain to Tracy how you're solving the problem, what you're doing, instead of just doing it in your head. Okay?
Okay, so I would see which one is divisible by the greatest number. So if I divide 48 divided by 4, which I would get 12. I'd have to divide 28 divided by 4 too to get 7. And then, but that's not the greatest common factor. So I would make a list of the factors.
So do you want to make a list maybe right here?
Yeah.
Okay. So when you do this, if you're starting out low and we're looking for the greatest common factor, you don't start high and go low? Is it easier to go low than to high?
It's easier to.
Okay.
Wait, so do I erase it?
No, you're good. Keep going. Let me move you over a second.
Okay.
Okay, we'll move all this over, see how cool that is. And we'll do that. Now keep going. So we know 1 can go in, 2 can go in, 3 can go in, 4 can go in, 5 because there's no 0 or 5 at the end, right?
Yes.
And we know 6 can go in, okay?
Yes.
And 7?
No.
No, okay.
8, and then it starts going up,
Okay.
and then it goes.
Do you need more room?
I can just go here.
You want to go down? Okay.
Yeah.
so you're going up by 8, 8 goes in, 12 goes in, 16 goes in, 24.
Yes.
Are you going all the way up to 48?
Yes.
Okay, so we need to get it to be like 28, right?
Yes.
So let's stop right here. Can 28 go in there?
No.
So let's stop right real quick and start on the 28. Because it can't go higher than 28, right?
Yeah.
Okay. Okay, so 16, 12, 16, 24 can't go in there, right?
Yeah.
So now what do you do? How do you look at that and say which one's the highest?
So I would look at this and figure out which ones are the same. And so 1, 2, 3, and 4 are the same for.
So these are all the same?
Yeah.
So, but they're little, right?
Yeah.
So we'll put a line just so we know they're gone. Okay, go ahead.
So,
Do we have a 7?
no,
Do we have a 14?
no,
Do we have a 28?
no.
So what's our greatest one then?
The greatest one is 4.
Perfect. That was awesome. Do you guys do trees still? Where you draw the
Yeah.
little tree? I love the trees. Okay, you go. You finish it.
Here, let me move the screen a little for you, Brian.
you. There's lots of 2s there, huh?
Yeah.
Okay, now we're gonna do the 28. Let's just move over a tiny bit so we have a little bit of room. There you go.
So 2, 2, and 7.
2, 2, and 7. Okay, well, we know we don't have 7, huh?
Yeah.
So we can just cross that little, like, bye-bye. It goes away. Okay, do we have 3 over here?
No.
No, so 3 is like bye-bye. So now what do we do?
We count how many 2s there are.
Uh-huh.
So there's 1, 2, 3, 4, 5, 6 2s. And then so, you're right, 2 to the 6th power.
So if it's the greatest common factor, what's the greatest common factor? Is 2 the greatest common factor?
No.
No. How many 2s are over here?
2.
How many 2s are over here?
4.
Can we eliminate some over here? So how many would we need over here for it to be even?
So you would need 2 less over there.
So if we cross these off, because they don't mean anything to us,
You have to cross these off.
no, because we're even now. Aren't we even?
Oh, yeah.
So what's our greatest common factor?
Our greatest common factor is 4.
Correct.
There you go. Nicely done. Congratulations on that. Hey, we do have phone tutors available until 5:30 this afternoon, as we do most Tuesdays and Wednesdays throughout the regular school year. Right now, we're going to go out and about. We are heading to North High School and visit with Scott.
Hey, we're live here at North High, a little math in the real world, and it's amazing the real things that you can do on a high school campus. We've already been to a place where they had a real live bank on campus, and now we want to see what's going on here at North. Today, we're going to talk with Pete Keys, aerospace instructor. Mr. Keys, thanks for your time.
You bet. It's
I
a
appreciate
pleasure.
you letting us be here.
Sure thing.
So we're in a really large high school classroom, and there's a lot of stuff going on in here. First of all, how long have you been here at North?
I got here at the beginning of the school year,
Okay.
so I'm brand new.
So this is kind of exciting for you too, right? You
Absolutely.
get to be that kid first thing in the flight simulator and be excited about that. And your background, can you tell us a little bit about that?
Sure. I retired from the Air Force last May,
Okay.
so started growing my freedom beard and turned into a high school teacher.
Good deal. Well, we're glad you're here. It sounds like your experience certainly lends itself to being here. Now, this room you teach aerospace. Correct. So kids are going to go in outer space.
We cover everything.
Okay. Tell me a little bit about aerospace, because people probably don't know, including me. I don't know what aerospace it really encompasses.
From the ground up, the stars are the limit.
Okay.
So we primarily work with airplanes. Obviously, we have a lot of devices to train kids, and there's an airplane pilot shortage, as you know.
Right,
So that's a booming field that kids should be researching and thinking about.
Right.
But from there, we also talk about drones. We talk about rockets. They get basic theory on a lot of these things. Pretty much if it goes up into the sky, we're interested in it.
Right, and that totally makes sense, and that's going to, of course, combine science and math together, right? You got to have some physics about how things go up in the air and stay there, and you certainly have to have a lot of numbers you got to work with as well.
Absolutely.
So when you're talking with these students about aerospace, whether that be a drone or anything all the way, like you say, to the stars, what kind of students are involved in your program, and like what are they studying, or sorry, what level are they? Are they freshmen, sophomores, junior, seniors?
Full spectrum.
Oh, good.
So between the 4 courses, we cover from freshman to senior.
Okay.
So all different ideas of what they want to do in life. Not every single one of them wants to be a pilot.
Right.
Which is great because we have a wide diversity of curriculum that we cover. So we're interested in all aspects. Hope soon to build our own airplane here in the classroom.
Oh, wow. What a great, unbelievable project. So tell me, can a student be in your program for all 4 years of their high school career?
They can.
Okay. So we have well, I want to see a little bit about what you have going on here in this room.
Sure.
And of course, the first thing that catches my eye are these amazing flight simulators. So can you tell us a little bit about, first of all, who's with us?
All right, these are static Redbird simulators. We got Nicholas right here on the right, and Dylan over here on the left.
Okay, so let's look at what Nicholas is looking at here. Tell us a little bit about what he's looking at. This is he's simulating flying what kind of plane? Does it matter?
He's flying a Cessna 172,
Okay.
and he's in the Bay Area over Hong Kong, and we've got simulations set up for him to practice approaches into Hong Kong International Airport. He's
So
got
he
it
has
all
a
to
left and
himself.
right, like he's looking out the window, and then of course a control instrument panel type of thing here.
Correct.
And he's actually holding on to,
Yep.
something similar that you would actually see in the plane, right?
Correct.
And he can fly this plane, this simulator by himself. Is that right?
Absolutely.
Okay. And he even has pedals at the bottom.
Rudder pedals to control.
Now, is this an internet-based software deal, or is it kind of just local within this computer
It
right
is
here?
attached to the internet for maintenance, but it is not required to run the simulation.
Okay.
We get good updates like weather.
Right.
If you go to New York in the wintertime, you'll see snow. It changes with the seasons, and all of the environment cues are there.
So when you're talking about simulate, you want to simulate everything, not just the mechanics of the plane, but certainly what the outside atmosphere is doing, because that's going to affect the flight.
Yeah, it's free travel for them.
Yeah. Let's go over here to this next one. Anything different about this simulator? This.
Dylan's flying the same simulation. He
Okay.
is on glide path here, and what he is striving to do and practicing is just maintaining his focus down to the runway, his sight picture.
Okay. And he can adjust almost every part of this, right? Up, down, left, right.
You know, it handles like a 172, and the avionics and everything's interactive, that you'd see as professional pilots. All the data displays and everything there that you would want to practice with. It's really an FAA certified device.
Wow. So a pilot that was really going to go and get their pilot's license could use this as practice time, right? Or probably should use this without burning fuel, without being in a super dangerous situation.
Yep, that's the goal.
And what kind of training do these students have to do before you actually allow them on this really fun video game, right? I mean, because of course, when a student comes into this room, they're going to say, "Put me on that simulator. It looks like a video game," right? But you have to know some stuff first.
No, they know to respect it. It's not, it doesn't have any token slots. It doesn't spit out tickets. So yeah, they are expensive in their investment, and to get to this point, they do have basic aerodynamic training control of aircraft, so they learn some basics before they actually touch this.
And they've done some book work as well, so they know the theory behind flight and then what they need to know in order to understand what's going on in case the entire board goes out, right? Then they have to know what's going on. We've been to the airport and talked with some flight instructors, and that was one of their big things. Hey, you got to be able to fly even without these instruments. Know a little bit of math in your head.
Correct.
And so they got to have some background there. Really excited to see the rest of this place. We have a lot more to see. When we come back, we're going to see if we can talk a little bit, of course, more about math and how that is involved with aerospace and flight. And then, heck, who knows? Maybe I'll even get in one of these simulators and see if I can avoid crashing. But I know at the moment we probably have some math to do back in the studio. We'll get back there right now.
All right, thanks for that, Scott. And I fully expect Scott to be on a simulator later on, because I think we had Mary Lou, when we went to the Bakersfield Flying Club, actually sim one of the simulators and give that a try. Anyway, we do have phone tutors available until 5:30 this afternoon. Right now, we'll go to the phones. And Caitlin, how are you today?
Good, how are you?
I'm wonderful myself. Are you working on your robot family frog feast?
Yes.
Okay, so here's what we're going to do, because there are a lot of students that are going to be watching that have no idea, and there's a backstory to this. So do you mind if I just read the story first?
Yes.
Okay, because Brian is here and he's going to be working on this also, because you guys are in the same classroom and have the same homework. So what we're going to do is I'm going to go ahead and read the backstory first, all right? So Tin Man the robot felt a lot of stress as he moved from here to there in his kitchen. In a few hours, exactly 21 of his closest friends and family would be arriving for dinner. Robots, as you know, love to eat frogs. Thus, the main dish Tin Man plans to serve is boiled whole frog with a minnow garnish. From experience, Tin Man knows that 5 whole frogs will serve exactly 2 people. You know what? Let's write that on the board.
Okay.
5 whole frogs will serve 2 people. So 5 frogs equals 2 people, let's say.
Let's put an F for frogs, yeah. Equals 2 people, 2P. Okay.
And that he'll need at least 25 minnows per person to
So we'll do
squish into a
25.
rather tasty sauce
And we'll do M
that he
for
can dip the
minnows.
boiled frogs in. Sounds lovely. 25 minnows per
Equals
person.
1P. Okay.
All right. Tin Man owns only one pot that can fit a maximum of 7 frogs at once. So in a pot, he can fit 7 frogs.
So we're going to put 7F. And
So
we'll
you've got
do,
7 frogs will go into one pot.
so put equals 1 and put pot. 1 POT. Because we already put P for people. Okay.
All right, let's see. My mom taught me that it takes 15 minutes to boil a frog through to its guts. So I better
right.
get cooking. So
One
15
frog.
minutes to boil a frog.
1F equals 15 minutes. So put
A nice little
15
story we have going on. Right?
MIN. Okay.
As Tin Man started to cook, he recalled that he needed to take a trip to the store to buy beverages for his guests. He knew that each robot would need 1/2 quart of oil.
So we're
So
going
a
to
robot needs a 1/2 quart of oil.
1/2, and we'll just put Q for quart equals per robot,
Equals 1 robot.
1 robot. Perfect.
Oh,
We're good.
And he could buy the cheapest oil by the 5-quart case
Okay, we're
for the
gonna come
sale
over here.
price of $11.42. So you can get 5
Put
quarts
5Q
for
equals
$11.42.
11.42.
$11.42. And make sure we
$11.42.
put a dollar sign up there so we know that that's money.
Perfect.
It was then that Tin Man's robot girlfriend called to ask what time she should leave her apartment for dinner. Well, said Tin Man, the party's at 5:00 p.m. and you live 30 miles away with a speed limit of 60 miles per hour.
Put 5 o'clock.
So 5:00 is when the party starts and she lives 30 miles away.
And then just put 30 miles. We'll remember that. And what is the speed limit?
60 miles per hour.
So we're going to write 60 miles, and we'll know that's the speed limit.
So just 60 mph. There you go, 60 miles per hour.
Perfect.
All right, Kaylin, so that is the same story you have, correct?
Yes.
All right, read the problem that you have. So what's the first question you have?
How many frogs is Tin Man using to cook the main dish for his dinner guests? How many minnows does he need to make the garnish?
So we need how many frogs and how many minnows? That's our ultimate.
That's the first question.
Okay. Okay. How do we figure that one out? First of all, we're going to move all this stuff over because it's not important right now. So let's just move this real quick over here. And we'll move this one over here. Okay, and we'll move this one like over here. So this is the frogs and this is the minnows. That's our only ones we're dealing with right now, okay?
Okay.
Okay, so how do we do it?
So,
How many people are coming to the event?
21 of his closest friends.
Okay, I'm going to put 21 people. Okay, so
Now-
how do we figure that one out?
Before you start,
Okay,
he has 21 people coming over. Do you think Tin Man will be eating himself?
yes.
So how many people do we really need to serve?
22.
There you go. I don't want you to do a lot of math and then forget about the guy serving everything. He needs to eat also, right? So go ahead.
okay.
So, for 2 people, there are 5 frogs. So we should divide 22 divided by 2 equals 11, and then multiply 11 by 5 to get how many frogs we need.
Now, Kaylin, do you agree with that?
Yes.
Okay, so what again are we going to do here?
We're going to divide 22 by 2 to get 11, and multiply 11 by 5.
So we're going to take the 2 and we're dividing it by the 22 and we got 11.
Yes.
And then we're going to take the 11 and multiply it
Yes.
by
5.
5. Okay? And what would our answer be?
Our answer would be 55.
Okay? So we need 55 frogs. So right here, we're going to write it in red, 55 frogs. It's our first answer. And you're good. We'll know F means frogs. Okay.
Oh.
You're good. Okay, now to the minnows. Boy, doesn't that sound good. What do we need to do for the minnows?
So for the minnows, we know that there are 22 people eating, so it's the 25 minnows per person means you multiply 25 by 22.
Okay,
To
you want to
get-
do that?
Yeah.
Okay. Here, let me erase all this for you. Make it go away for you. Okay, go ahead. It's a lot of minnows, huh? It's like, what, 550 minnows? Wow. Okay, so you're going to write 550 minnows right there. Okay. I think we're done with the first question.
Right, so Kaylin, does that satisfy the first question? How many frogs and how many minnows?
Yes.
All right, nicely done right there. Nice that you guys agreed on how to solve that first problem right there. You know what, Kaylin, keep viewing the rest of the program because I'm sure we'll have Brian continue working on more of this problem as we go later in the show. Hey, we do have phone tutors available until 5:30. The phone number's at the bottom of your screen periodically throughout the program. We'll be back with more right after this. Today we're at Cuyama Elementary School, home of the Bears, and we're here to Well, today we're at Cuyama Elementary School. We've got some students from 4th and 5th grade ready to work with some pattern blocks, make some designs, and talk about the attributes of them. You guys ready to go?
Yes.
All right. So here's what I want you to do. First of all, I'm just going to dump about half of this bag for you guys. I'm going to dump some over here for you guys. What I'd like you to do is just grab a couple of the shapes. Doesn't matter which ones you grab. All right. Now that you have the shapes in front of you, let's talk a little bit about them. All right. So, what's one shape you have in front of you?
A square.
You have a square. Which one is the square? Okay. Now, how do you know that's a square? What about it lets you know that that's a square?
It has 4 sides.
Okay, it has 4 sides. But are there some other shapes that might have 4 sides? Like this has 4 sides, but that's not a square, is it? So how do you know that's a square and that's not? Can you guys help them out? How do you know that this is a square and this is not? Because this has 4 sides and that has 4 sides. But you guys all agree this is a square?
Yes.
And that's not. How can you tell? I mean, what is there about this that's different than this?
It has 4 straight sides.
Okay, there's 4 straight sides, right? Does this have 4 straight sides, though?
No.
Is that, yes, you see, yes, right? So that has 4 straight sides, right? So what else is different about it? How about you guys over here? Do you guys know? Because what we're doing is we're looking at this and this, right? And they said that this is a square, right? You guys all agree with that, right?
Yeah. Yeah.
And we want to determine how we know it's a square, because you said it has 4 straight sides, right? But this has 4 straight sides. What else? How do we know that that's a square?
Because whenever you look at this one, it has an angle like a triangle, but this one has a wider triangle because you can split it in half, but if you split this one in half, it's not the same as this one. Because if you put this one on, it's not the same. If you put it on this one, it's the same.
Okay, so if I had 2 triangles like that, it would fit on there, right? You're saying that this wouldn't be the same as if I put it on here, right? But if I did cut that in half, wouldn't it be 2 triangles again?
Yes, but they're not the same as the triangles on here.
Right, so the triangles would be different. Now you're getting on the right track here because the angles are different here, aren't they, than this one. So that's kind of what we're looking for. What is the difference in the angles between these 2 shapes? What have you got?
Because on the diamond, it's like going at a diagonal angle, and then on this one, it's like just going straight.
Do you guys know what those angles are called? Have you guys studied angles in triangles before? Have you guys ever heard of acute angles?
No.
Obtuse angles?
No.
Right angles? You guys have heard of some of those? All right. So if you take a look at the square, all of those are right angles. They measure 90 degrees. All right. The other ones have acute and obtuse angles. They're greater than or less than 90 degrees. You guys get that? Yeah. Okay. So take a look at some of the other shapes. What other shapes are there?
There's a circle.
Okay, we've got a circle. What else have we got?
Triangle.
Triangle.
We have a
Trapezoid.
Trapezoid, right? So there's a lot of different shapes, right? Can you take any 2 shapes and reproduce a single shape? Like you were saying, if you took 2 triangles, right, then you would make, right? Are there any other shapes where you could take 2, put them together and make 1? There you go. And what did you make by using both of those?
an octagon.
An octagon has how many sides, do you know?
8.
8. And how many sides are on that?
6.
6. All right, so we're just starting our exploration into different pattern blocks, the shapes, the attributes of them, angles and sides and things like that, and we'll be back with more right after this. And that certainly was a lot of fun going to visit the staff and students at Cuyama Elementary. We had a lot of fun out there with the students. We do have phone tutors available until 5:30 right now. We have another opportunity to see more about the aeronautics program at North High School.
Hey, thank you. We're back here live at North High, and we want to know a little bit more, of course, about how math applies to any kind of aerospace program. So Mr. Key is going to show us a little bit about how math enters into the classroom in his classroom, right? And I love this presentation. We got a chance to look at it a little bit, but can you explain to me again? We talked a little bit about triangles, right? You're going to show us a flight triangle, is that right?
Triangles. Why are they important? Why should I care?
Yeah.
We study triangles a lot. So pilots like to fly this glide slope down to the runway. So it turns out to be a 3-degree glide path all the way down. So the hypotenuse of the triangle is the descent rate performance factor. This leg right here is representative of altitude lost over time. And this right here at the top, this leg, is the distance.
Okay, the distance from where they are currently into the spot where they actually want to land,
Correct.
right?
So to better, more accurately control our aircraft, we want to solve for some of these problems here. We want to know the altitude over distance and the descent rate. So we control our aircraft with this banana right here. We put the little point of the banana there on the line. If we change this banana by 1 degree over 1 nautical mile, we are going to change our altitude by 100 feet. It doesn't matter if you're in a little tiny Cessna going 60 knots, or if you're in an F-16 doing Mach 1.2. You are going to change your altitude by 100 feet. Now, obviously, the speed along that line is going to change, and that is going to affect our performance. So bringing us to our 3-degree glide path, obviously 1 times 300, 1 times 100, 3 times 100
yeah.
is 300 feet.
Right.
Thank you. I needed a math professional to help pilot math in public. So if you extend that triangle out further, longer, so double that, you're going to increase 600 feet,
Right.
and so on and so forth. So we're interested in how many miles per minute we're doing, and the math is easy as it turns out in a Cessna. If we're doing 60, we're doing 1 mile per minute.
And that's a wonderful correlation to any students who are getting ready to drive, right?
Yeah,
Because
absolutely.
60 miles per hour is a classic, typical speed that you can work with and do some simple calculations.
Mom, are we there yet?
Yeah.
So we can interpolate, obviously, with the other math there in increments of 30 and see how those relationships change. If we double it, that's an easy one, 120. We're doing 2 miles a minute, so on and so forth. So we have a gauge in our cockpit that measures feet per minute of change. And so we look at the chart and we see that for 60 knots, we want to see 300 feet per minute on our gauge.
Right.
And that's measured right there in our cockpit.
Oh,
so
there you
to
go.
follow that glide path all the way down to the runway,
Yeah.
we'll make sure that number is in there. And
And of course, it even has a
stabilized.
negative sign on it, which means you're descending, right?
Correct.
Yeah, and you can see your banana over there is not exactly on the line, and that's how you know you're going down, right? Because
Correct.
you have it, if it was exactly on there, you'd be staying at the same altitude, is that right?
Pitch and power settings.
Right.
And then backing that up with math to see how it's performing.
Yeah. Now, right before we go on, I have to ask this really ignorant question, but I'm so curious. Tell me about the 3 degrees. What would happen if you at 5 degrees, or what would happen if you were at 1 degree? Like, what's the why is 3 degrees optimal?
Your descent rate's going to increase.
Okay.
So basically it's concluded to be the glide path that is most comfortable for pilots
okay.
and passengers. They even choose a 3-degree glide path when they descend from way out,
Right.
entering in from 35,000 feet to getting close to LA airspace.
Right.
They will do that math, altitude to lose times 3 will give you the distance. So if I'm
Okay.
at 35,000 feet and I need to, multiply that by 3, then I know,
Right.
how to get down quickly.
Yeah, and I like the word you used there. It totally makes sense to me as an airplane passenger. It's comfort level, right? I
Yeah.
mean, it makes sense. I would be uncomfortable if I felt like we were falling faster than we should be, and I would be a little less comfortable if I knew that our descent path was 3 times as long as it should be if you're only going down 1 degree.
Mm-hmm.
So, okay, 3 degrees makes sense. All right. Anything else we need to know about when the students are on the simulator, about all these numbers that they see on the screen? Because to anyone who hasn't done that before, there's a lot of numbers there.
Oh, you talking about this chart here? Yeah, obviously your speeds change, so wind could affect you.
Right.
So, they may think that they may never be going, slower, but you hit a headwind, and suddenly that's going to change your performance rate on your glide path.
Yeah.
And you need to be able to compute that. So it takes them from pilots of being, that looks about right, to actually being able to calculate it and know that that is right, and this is what I'm looking for.
Yeah, yeah. Now, in your classroom, if you're giving a test, do you ask questions like this? Do you ask mathematical questions where you say your plane is so far away from the runway and you need to know how quickly to descend, or you need to know when to start your descent, or something like that? Like, I don't want to know about these test questions, and the students do too. What are you going to ask them about?
I do, and the FAA, when they go for their pilot's license, they'll be required to do some math,
Right.
and they'll have tools to do that with. It's not on their fingers and toes. They'll figure it out by then.
Right,
Yeah.
right. So obviously there's got to be a lot of software that can do those things, but if you can have a generalized idea of what's going on behind the software, that certainly is going to be helpful. And we know that from visiting with the air traffic controllers we did a couple shows ago. So I know there's some more math to do back in the studio. We are going to get to talking about some drones when we come back, but right now we'll head back to the studio.
Thanks for that. A lot of aviation going on at North High School. We do have phone tutors available until 5:30. We've got Brian, a 6th grade student from Reagan Elementary, in studio working out some problems today. Right now we're going to go to the phones. And Ryan, how are you this afternoon?
Doing good.
Good. And you are in 8th grade, correct?
Yes.
All right. As soon as you're ready, let's hear the math problem that you're working on.
Okay. 2n squared minus n plus 3 open parentheses 2n plus 1 close parentheses.
Hold on 1 second. Should we move everything over? Because, I didn't leave enough room. Okay. Okay, go ahead.
Equals 15n plus 3.
Okay, and it was Ryan, correct?
Yes.
Okay, Ryan, you want to help me out on this problem and tell me what I need to start with?
Sure. So I believe you start with the distributive property.
Okay. So how would I do that?
You distribute 3 to 2n plus 1 inside the parentheses.
Okay, so it would be 3 times 2 would be 6n, plus
Yes.
3 times 1 is 3. Okay?
Okay.
Now what?
Then you combine like terms.
Okay, how do I do that?
On the first side, negative n plus 6n equals 5n.
Negative n plus the 6n is going to equal what?
5n.
Great. Okay, so now we have 2n squared plus 5n plus 3 equals 15n plus 3, correct?
Yes.
Okay, great. Now what?
We subtract 3 from both sides.
Okay, so what we do to the left, we do to the right. That crosses those two off. Okay, great. Now what do we do?
I think we subtract 5n from both sides now.
Got it. So I'm going to rewrite the problem just so we have it clear, because we keep moving things around and combining stuff. So you're telling me I need to now subtract from the left the 5n, and from the right, because what we do to the left, we do to the right. Therefore, we have 2n squared. These cross each other off, equals 10n. Is that correct right now?
Yes.
Okay, go ahead.
And now I think we divide by n.
Okay, so what do you call it when we do like the opposite of something? So is this multiplication 2n squared? Isn't that multiplication?
Yes.
So what are we doing to be able to do? Because it doesn't say to do division. Is it something that you're learning in school?
Are we multiplying by its reciprocal?
Ah, nice. We call it inverse operation, but you did a great job. So now we're dividing, correct?
Yes.
Okay, so we're dividing by 2 from each side?
Yes.
Okay, let's try that. So then the 2's cross each other off. So we have n squared 2 goes into 10, 5, n. So we have n squared equals 5n.
Yes.
Okay, now what?
We divide n from both sides.
Okay, so if we divide n from both sides, then we would end up with the two n's cross each other off. So what's our final answer?
N is equal to 5.
Because we have two n's on that side, so it'd be n is equal to 5. Very nicely done. Couldn't have done it any better. That was a great job.
Ryan, congratulations on doing that problem. For that problem, you've got yourself a couple of tickets to go see the Bakersfield Condors. I think the Condors have won 12 games in a row.
Nice.
So they are on quite a streak, and they might be playing tonight, as a matter of fact, but we can't get the tickets to them that quick, but you'll be able to go after that. You ready to do some more work?
Yeah.
All right, let's go back to the problem that you were working on. And we know that you had these frogs and minnows and all of this stuff, all right? So the next problem was, what length of time will it take Tin Man to cook all of the frogs that he needs?
Okay, so we're going to move this down, and we're just going to put length of time. Length of time. Okay?
Yes.
Okay.
So he
So
can
you-
cook 7 frogs at once. And it takes 15 minutes to cook the frog.
Okay. This is 15. Well, that's just not working, is it? We'll write 15 minutes per frog. 1 frog. Okay. So now what do we do?
So, since we want 22 people, then we multiply 22 times 1 equals, 15 minutes times,
So how many
Oh,
frogs do we need
we need 55 frogs for,
for that many people,
20.
right?
yes.
Okay, so we don't need this anymore. We're like, bye-bye. Okay, let's put a line through it. So, but we need to know there are 55 frogs, right?
Yes.
Okay, so then if there's 55 frogs, so write 55. And we'll put a line underneath it so we know.
The 55?
Nope, right here. Okay, and then put a line underneath here. So what we're looking for is this right here, correct?
Yes.
So how do we do that?
So, we do cross multiplication and simplify.
Okay, let's see what happens.
So divide both by 5, you get 3 minutes over x equals 1 frog over 11, because you divide 55 divided by 5, and then so that would be 3 over 11x.
Okay. So if we need 15 minutes for 1 frog, and if 55 frogs is what we need, can we just multiply 55 times 15?
Yes.
You want to try that?
Okay.
Okay, so let's just do this real quick. It's a big number, but it'll be a little bit more simplified. So we have 55 times. Okay. Perfect. Let me move you down a little bit. There you go. It's a lot of minutes, huh? Yeah. Okay, so if we have 725 minutes, can we make that into how many hours?
So divide that by 60.
Okay.
So
There you go.
to divide by 60, I would put a 1 right here because 60 doesn't go into 7.
Correct.
And then subtract 60, you get 12. And then bring the 5 down, and then can only go in 2 times.
So it's
Now,
like,
before you keep going, I want to ask you this. Because you can cook 7 frogs at once,
yes.
you're doing this where you're cooking 1 frog at a time.
Oh.
So you can cook 7 frogs at one time. So maybe take the total number of minutes and
So
do what with that?
Divide by,
In other words,
Divide
you'd be
by
cooking into the next
7.
day.
divide by 7. Okay, so we had 725 divide by 7. Now let's do that.
Okay. So
Oh, I bet it makes it a lot easier, huh?
yeah.
Yeah.
Wait. 103. 103.
Approximately 103.
Okay, so we're going to let you guys keep working on this for the number of minutes that you need to totally cook these frogs. And right now we're going to go for our final visit out to North High and see how the aviation program is going with Scott.
Hey, we're back here live at North High, and of course we've been talking with Mr. Keys about all kinds of aerospace things. Thanks again. We want to make sure that we talk a little bit with Mr. Walker, who is the CTE coordinator here at North High. Thanks for being here with us. I appreciate it.
Absolutely.
What do you teach
My
here at
pleasure.
North?
I teach geology and I teach photography.
And that has absolutely nothing to do with aerospace at all.
Well,
Not true, not true. We're here in front of some drones, and of course, a lot of young people know about drones, maybe even have one of their own that you can buy, a recreational type of thing.
Yeah, absolutely.
But for your fields of study, photography and geology, tell us how we would use drones in those areas.
well, drones are changing both industries, especially photography. Having a drone is like having a 300-foot tripod.
Right.
And that gets pretty heavy lugging around. So having a drone and being able to get to places that normally we couldn't get to, for videography, we don't have to rent helicopters anymore. And so that reduces the cost quite a bit.
Yeah.
For geology, mapping, surveying areas, we get to see a lot of ground very easily and
Yeah.
economically.
Yeah. And of course, here in Kern County, that's big time. So you're talking about the oil industry, which
Oil
really wants to
industry.
know about geology, excuse me.
Absolutely.
And what else?
Surveying pipelines for oil.
Right.
Agriculture.
Agriculture
huge
really
surveying
wants
crops.
to know about the layout of their crops and what's going on there, right?
There's things like real estate and
Oh, wow.
wedding photography and so many things that we don't even know that we're going to use drones for.
Yeah,
Yeah.
Okay, so let's talk a
Endless.
little bit about the actual aerospace part of it. Mr. Keys, tell me about these specific drones we're looking at and what we need to know about drones, because they fly differently than an airplane, of course, right?
Certainly, and
Yeah.
there's rules involved too.
There are rules
yes,
involved,
you shouldn't
yeah.
just buy one of these and launch it from your backyard.
Okay, good to know.
Yeah, make sure that you get online and look at the requirements. Or
Okay.
The FAA, which is now regulating these things, might get upset with you.
Right.
And it's basically airspace study. So you have to learn your airspace and the rules and requirements, particularly around airports and how planes operate, so that you keep it safe and you
Yeah.
don't fly into the path of an airplane.
That completely makes sense. And of course, here at North High, you're close to the airport, so you have to watch out for that. So we couldn't just take this with a class and go outside and launch it up in the air and do some funny things. We'd have to really make some plans and know what we're doing and have a license to fly it. Is that right? Wow. Okay, so there's a lot more to drones than maybe we know initially, anyway, because they certainly look like a lot of fun, right? Remote control. We all remember being a kid and making sure we had that remote control and have a lot of fun. Now, when a drone's up in the air and we're doing some photography, we can send that signal back so we can see what's going on the ground, or is it just recorded in the drone and the data comes back later?
You're seeing everything from whether it's the remote, whether you have an iPad connected to it, you see exactly first person what the drone's seeing.
Right.
And so you're able to get your shot. You can fly first person. You always need to have a spotter that's a visual observer, making
Yeah.
sure that nothing's in the way if you're using a monitor like that. So-
Right, right. Okay, so we see some unmanned aircraft, and then this is the granddaddy of it all. I really want to see this machine over here because this is the official flight simulator, right? It says
Redbird FMX.
Redbird on the outside. Who are all the people that signed here? These are
we've
famous
got,
pilots?
Famous stunt pilot Sean Tucker right there.
Nice.
We've got Tony Tancaponte. He is a U-2 pilot with the Air Force.
Okay.
We got Mr. Fred Webster, American Airlines.
Wow.
Chooch is a Redbird guy who's talked to us and give us some instruction. And then Mr. Don Hitch, who's also a wonderful local guy who's worked for the wonderful aviation company.
Wow, and this is a true simulator. I'm going to get in here and see if Salem here can show me a little bit about this simulator. I mean, this is like really flying in an airplane, right?
Yeah, it is. It's just like it. So it simulates the pitch and the turn, so it'll actually move with it.
Yeah.
I'm right here at Bakersfield Meadows Airport, 30.
Okay, this is a simulation of this airport.
Yeah, so you can put.
All right, I better
type
buckle
it
up.
in. Yeah, you can go anywhere that you want in the world.
Wow, get us in the air. Let's
right.
do it.
So let's start.
And the craziest thing about this is it truly feels like this whole thing is moving forward. Whatever the hydraulics are with this machine, like this is an actual simulator, not just on the screen, but in the feel. You did something there where it feels like we're definitely moving. That's amazing.
So right at takeoff, it starts to lift you up just like you're on a roller coaster.
Unbelievable. And there's all kinds of programming, of course, that goes along with this because you have to have this view all the way around. Now tell me, when you are doing a simulation like this, which numbers on this screen here are you looking at?
So I'm looking for my airspeed right here.
Okay.
I want to make sure that I'm in the green area right here. And then I'm looking for my altitude.
Okay.
Make sure that I level that out.
Right.
And then when I'm climbing, I want to stay at the Y. That's my best rate to climb.
Okay.
So this on this side, this is what I'm looking for. Over here is our navigation. So this is where we just landed off at. You can zoom it in really big, or you can go out.
Wow.
And it'll show you everywhere you need to go.
That's crazy. Now, have you pre-programmed a course to go? Like somewhere to go right on this trip right here?
Today I have not, but you
Okay.
can program everything that you need to do, and then you can let autopilot take over as soon as you get off.
Right. Oh my gosh, this is unbelievable. And so each touch that you do, you have pedals, you have a steering wheel, right? I'm not a pilot, so I don't really know.
Yoke, but yeah.
A yoke, okay, you have a yoke, and you have all these instruments and things that you can adjust, right? But it can take you on the course, and really, I mean, I still can't quite explain to anyone who's not in here, but it feels like we are moving. It feels like we are actually, this whole entire vehicle is moving through the air.
So if you notice, so like it's kind of like rocking back and forth
It
right
is,
now. It's because
yeah.
we're going through the clouds. It's simulating that.
Yeah.
You can
Yeah.
simulate everything from.
Look at this, right here in front of the simulator. We're going to put the Do the Math tile. We really appreciate you letting us be here. Thank you, Salem, for taking me on a trip. We'll go back to the studio now and maybe do a little bit of landing here. We won't film that part though.
All right, thanks for that. Big thanks to North High and that aviation program for having us come visit this afternoon. We do have phone tutors available until 5:30 this afternoon. A big thanks to Brian. And once we decided that you could do 7 frogs at once, it came out to a different answer, wasn't it? Yeah, a little bit easier. All right, well, congratulations on that. Hey, and until we meet again, you continue to do the math.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Kern Schools Federal Credit Union, California Resources Corporation, Bakersfield West Rotary Stroop Family Foundation, Panama Buena Vista Union School District, Bakersfield City School District, and the Kern High School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.